Hi everyone. Today I'm going to talk about a very, very, very big number. A super, super, super big number. And that is 3, 3. So the tree sequence is a very fast growing function arise from the graph theory. And 3, 3 is the smallest number in the tree sequence that is bigger than Graham's number. In fact, 3, 3 is one of the biggest number ever used in mathematics. And the Kruskal-Tree theorem states that such a sequence cannot be infinite. That means for any finite number of n, let's say the function n here, so whatever number you put in here, as long as is finite, the tree sequence of this number is going to be finite. So given k, what's the maximum length of such sequence? So the maximum length is a function of k, dubbed 3k. So in this sequence, if you put in 1, so 3, 1 is just 1. So not very big so far. And for 3, 2 is equal to 3. Still nothing too special. But once we get to 3, 3, it becomes an extremely, extremely huge number. Much bigger than even Graham's number. So you can see how crazy is that. This is a very, very, very fast growing function. One of the fastest in mathematics. And definitely the fastest that we've seen so far. So it jumps from 1 to 3 to a number that is way bigger than Graham's number. That's crazy. So nothing in physics or in the real world can really be compared to this function. So even the fastest growing thing in the universe, which is the expansion of the universe, still it's nothing. It's nothing compared to this sequence. So only in mathematics you can see something like this. So how big is 3, 3? Maybe like compared to Graham's number, like is there any even a comparison that we can use? So a very, very weak lower bound for 3, 3 is this function here. So A stands for the Ackermann function, and the Ackermann function itself is a very, very, very fast growing function. It grows similar to the function used in Graham's number, which is the up arrow notation. So similar. And we can see here the very extremely weak lower bound for 3, 3 is this thing over here. So this thing stands for a to the a to the a dot 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 1, where the number of a's is a of 187196. So a stands for the Ackermann function, and there are this many iterated Ackermann function in this thing here. So this is a very, very big number. So in comparison to Graham's number is around, using the Ackermann function, Graham's number is around A64, 4, which is equivalent to A4, where the number of A's is just 64. This number here is clearly way bigger than 64. 64 is a tiny number, and this is a huge number by itself, and this is just the number of A's in this function. So that means even a very, very weak lower bound of 3, 3 is already much, much, much bigger than Graham's number. But 3, 3 of course is smaller than 3, 4. It's way smaller than that. And 3, 4 in turn is much smaller than 3 of 3 of 3. Da da da. And so on. And yet there's another function in mathematics that grows even faster than the tree sequence. which is the SCG function. The SCG stands for subcubic graph, and one of the number in the sequence, SCG13, is known to be much bigger than 3,3. But yet, this number is still a finite number, which means it's nowhere near infinity. And this number, SCG13, is one of the biggest number ever used in mathematics. Another way, just to show you how crazy the tree sequence is that in order to prove 3n is finite using only finite arithmetic, you would need at least this many symbols to prove it. And that number is 2 double arrow 1,000. So you would need 2 double arrow 1,000 symbols for your proof. And this number here means 2 to the power of 2 to the power of 2 to the 2 to the 2 da 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 da. And in this power tower there are 1,000 2's. So this is a very big number, much bigger than the Googleplex or Googleplex. So no one can ever finish this proof because there's the universe is gonna end. So that even assuming you start the proof from the Big Bang and you write each symbol for each Planck time, which is the fastest possible speed that you can write anything, and even that you start from the Big Bang all the way until the Poincare recurrence, still you're gonna be in nowhere in this proof. You're not even 1%, not even 0.00001% for this proof. So even if you can write down this proof, there's not enough space in the universe, in the observable universe, to even fit your proof. So this is another crazy thing about the tree sequence. And remember, this is just the proof itself, to prove 3n is finite. It's not even the number 3,3 itself. So there's just no way to show how big 3,3 is. At least for Graham's number, we can kind of visualize how big the number is using the up arrow notation. But 3,3 is just nothing. Not even up arrow notation. Not even the chain arrow notation, which is much more powerful than the up arrows. And no one knows how many digits it has, and nobody knows the first or the last digit. At least for Graham's number, we know the last 500 digits. But no one knows, and no one will ever know the last or first digit of 3,3. So it's pretty crazy. There we go. 3,3 is a very kind of hard to explain, and it's a very big number, way bigger than anything we've discussed so far. So thanks for watching, and have a nice day.